Question 1. Form quadratic equations which have the following roots. Before we start, I'm going to use SOR as the short form for the sum of roots and POR as the short form for the product of roots. So when the roots of a quadratic equations are known, then you can form the quadratic equations by using this, which is x squared minus the sum of roots x plus the product of roots equal to 0. Questions A. So the roots are 6 and 2 and 6. Therefore, the sum of roots equal to 2 plus 6, which is 8. And the product of roots equal to 2 times 6, which is equal to 12. Therefore, the quadratic equations for A is x squared minus the sum of roots 8x plus the product of roots 12 equal to 0. Questions B. The roots are negative 1 and 4. So the sum of roots equal to negative 1 plus 4 equal to positive 3. The product of roots will be negative 1 times 4, which is equal to negative 4. Therefore, the quadratic equations for questions B, x squared minus the sum of roots 3x plus the product of root, which is negative 4, equal to 0. So next, plus minus will become minus 4 equal to 0. So this is the quadratic equations for B. And for question C, the roots are negative 4 and negative 7. So the sum of roots equal to negative 4 plus negative 7, which will give you the answer of negative 11. The product of roots equal to negative 4 times negative 7 equal to positive 28. The quadratic equations for C, x squared minus the sum of roots, which is negative 11x plus the product of roots 28 equal to 0. So for this part, it will be x squared plus 11x plus 28 equal to 0. So this is the quadratic equations for C. And for questions D, the roots are 1 over 5 and negative 5. So the sum of roots equal to 1 over 5 plus negative 5. Solve this using your calculator. You're going to get negative 24 over 5. The product of roots equal to 1 over 5 times negative 5. Simplify this, then you're going to get negative 1. So the quadratic equations for D, x squared minus the sum of roots, which is negative 24 over 5 x plus the product of roots, which is negative 1 equal to 0. Let us solve for this sign first. X squared plus 24 over 5x minus 1 equal to 0. So the coefficients for the x here is in the form of fractions. So if you want to get rid of it, so we're going to multiply each terms here with 5. So for this, when 24 over 5, you multiply it by 5, this 5 will be cancelled. Therefore, you won't have the fractions anymore. So finally, the quadratic equations for D will be 5x squared plus 24x minus 5 equal to 0. Questions number 2. The quadratic equations x squared plus bracket p minus 5x plus 2 cubed equal to 0 has roots of negative 3 and 6. Finds the value of p and q. So the roots of these quadratic equations has been known. Therefore, we can form the quadratic equations based on the roots given here. To find the value of P and Q, later on we are going to compare the quadratic equations that is formed from the roots -3 and 6 with the quadratic equations given in the questions. So the roots is -3 and 6, therefore the sum of roots equal to -3 plus 6. The answer is a positive 3. And the product of roots equal to -3 times 6 equal to -18. So the quadratic equations will be x squared minus the sum of roots 3x plus the product of roots, which is -18, equal to 0. So let us solve for the signs here. -18 equal to 0. So now let us compare the quadratic equations that is formed with the quadratic equations given in the questions. So the coefficients for the x, which is p plus 5 here, is equal to the -3. So by doing the comparisons, p minus 5 equal to -3. Therefore, p equal to -3 plus 5, which is equal to 2. The c here, which is a positive 2q, is equal to the -18. So 2q equal to -18. So q equal to -18 divided by 2, which is equal to -9. Questions number 3. If alpha and beta are the roots of the quadratic equations 5x squared minus 10x minus 9 equal to 0, form quadratic equations with the following roots. Before we start, the sum of roots is equal to -b over a, and the product of roots is equal to c over a. So from the quadratic equations given in the questions here, we are able to determine the value of a, b, and c. So the quadratic equation is 5x squared minus 10x minus 9 equal to 0. The value of a is equal to 5. The b is equal to -10, and c will equal to -9. And alpha, beta are the roots for these equations. Therefore, we are able to determine the sum of roots and the product of roots of these equations. So the sum of roots in this case will be alpha plus beta, and this is also equal to -b over a. So the b is a -10 and a is equal to 5. So when you solve it, so we are going to have a positive 2 because negative is a positive. And for the product of roots, it will be alpha multiplied the beta, which is also equal to c over a. So the c is a -9 and a is 5. Therefore, c over a is -9 over 5. So now we have the value of the alpha plus beta, which is equal to 2, and the product of roots alpha beta, which is equal to -9 over 5. Now we can start to form the quadratic equations of a, b, c, d. So let us look at questions A first. So the roots of a here is alpha plus 2 and beta plus 2. So this quadratic equations, the sum of its roots will be alpha plus 2 plus beta plus 2. So I'm going to rearrange this. So alpha plus beta plus, so the numbers here are going to sum it up. 2 plus 2 is equal to 4. So as we know, the alpha plus beta have the value of 2. So I'm going to replace this alpha plus beta here with number 2. Therefore, you're going to have 6 for the sum of roots. And for the product of roots, for questions A, it will be alpha plus 2 multiply the beta plus 2. So we're going to expand this. So after the expansions, you want to have first alpha beta and then plus 2 alpha plus 2 beta plus 4. Now for this part, we will factorize it as we have a common factor of 2. So alpha beta plus, take out the 2 and put a bracket, alpha plus beta plus 4. Now from the informations here, we know that alpha beta is equal to negative 9 over 5 plus 2 times the alpha plus beta, which is equal to 2 plus 2. Solve this, you're going to get the answer of 31 over 5. Now we can form the quadratic equations using these informations. So x squared minus sum of roots, which is 6x, plus the product of roots, which is 31 over 5, equal to 0. Noted here, the c is in the form of fractions. To get rid of these fractions, multiply each term with number 5. So when 31 over 5 multiplied by 5, the 5 will be cancelled. Therefore, the quadratic equations will be 5x squared minus 30x plus 31 equal to 0. Questions B. The roots are 5 alpha and 5 beta. So first, we're going to find the sum of the roots. It will be equal to 5 alpha plus 5 beta. Here I'm going to do the factorizations as I have a common factor of 5 here. So 5 brackets alpha plus beta. So as we know, alpha plus beta is equal to 2. So I'm going to replace here with number 2, which will give you the answer of 10. And next, we're going to find the product of roots. In this case, it will be 5 alpha times 5 beta, which will give you the answer of 25 alpha beta. So as we know, from here, the alpha beta is equal to negative 9 over 5. So here it will be 25 times negative 9 over 5. Solve this, you are going to get the answer of negative 45. Now, the quadratic equations for B will be x squared minus the sum of roots 10x plus the product of roots, which is negative 45, equal to 0. So here we're going to simplify the signs here. X squared minus 10x plus minus will become a minus. 45 equal to 0. So this is the quadratic equations for B. Question C. The roots are alpha minus 1 and beta minus 1. So first we're going to find the sum of its roots. It will be alpha minus 1 plus beta minus 1. So this part is equal to alpha minus 1 plus beta minus 1. So I'm going to rearrange this. So it's going to be alpha plus beta. And for this number, negative 1 minus 1 is equal to negative 2. And for this part, alpha plus beta, I'm going to substitute it with the value of 2. You're going to have 2 minus 2, which is equal to 0. Next, we're going to find the product of roots. So it will be alpha minus 1 multiply beta minus 1. So we're going to expand this. So first you're going to have alpha times beta, which is alpha beta, and then minus alpha followed by minus beta, negative 1 times negative 1, positive 1. Now for this part, I'm going to factorize it, as this have the common factor of negative 1. So put a negative at the front, bracket, alpha plus beta plus 1. So alpha beta, I'm going to replace it with negative 9 over 5 minus the alpha plus beta, which is equal to 2 plus 1. Solve it, you're going to have negative 14 over 5. Now to find the quadratic equations for question C, x squared. Now the sum of roots here is equal to 0. Therefore, for these quadratic equations, you don't have the terms x. So straight away we're going to plus it with the product of roots, which is negative 14 over 5 equal to 0. So simplify the signs here, you're going to have x squared minus 14 over 5 equal to 0. So here we have a fractions. So to get rid of it, multiply each of the terms here with 5. So when 14 over 5 times 5, the 5 will be cancelled. So the quadratic equations will be 5x squared minus 14 equal to 0. Questions D. The roots are alpha over 3 and beta over 3. So first we're going to find its sums of roots, which will be alpha over 3 plus beta over 3. Now, for this part, we can sum it up straight away because they have the same denominator. So next it will be alpha plus beta over 3. So we know that alpha plus beta is equal to 2. Therefore, here is going to be 2 over 3. Next is the products of roots, which will be alpha over 3 times beta over 3, which will give you the answer of alpha beta over 9. So as we know, alpha beta is equal to negative 9 over 5. So this is the same as negative 9 over 5 divided by 9, which is the same as multiply 1 over 9. So this number 9 here, we can cancel it. Therefore, you're going to have the answer of negative 1 over 5. Now we can find the quadratic equations for questions D. So x squared minus the sum of root, which is 2 over 3x, plus the product of root, which is negative 1 over 5 equal to 0. So this is the same as x squared minus 2 over 3x, plus minus will become a minus. So for these quadratic equations, I have two fractions here. So one of it denominator is 3, another one is 5. So to get rid of the denominator, so I'm going to multiply all of the terms here with the lowest common multiple of 3 and 5, which is 15. So when 2 over 3 times 15, so here we can simplify it. And 1 over 5 times 15, so this 5 and this 15, we also can simplify it. Therefore, the quadratic equations for D will be 15x squared minus, here is going to be 2 times 5, which is 10x. And here is going to be 1 times 3, which is 3, equal to 0. Questions number 4. If alpha and beta are the roots of the quadratic equations 2x squared plus 5x equal to 1, find the quadratic equations with the following roots. So the quadratic equations that we want to form all contain alpha and beta. So from the quadratic equations given in the questions here, which has the roots of alpha and beta, therefore we can find the value of a plus alpha plus beta and alpha times beta using the relationship that we have here. So first, we're going to change these quadratic equations in general form, which is 2x squared plus 5x minus 1 equal to 0. Therefore, the a for this quadratic equation is 2, b is equal to 5, and c is equal to -1. So for these quadratic equations, the sum of its roots, which is alpha plus beta, is equal to this negative b over a. So the b is 5 and a is 2. So the alpha plus beta is equal to -5 over 2. And the product of roots, which is the alpha times beta, equal to c over a. And the c is -1, a is 2, therefore it is -1 over 2. So now we have the sum of roots alpha plus beta, -2 over 5, alpha beta equal to -1 over 2. Therefore, we can start to form the quadratic equations of a, b, c, d. So a, it has the roots of 1 over alpha and 1 over beta. Therefore, the sum of roots will be 1 over alpha plus 1 over beta. To form this as a single fraction, we need to equalize the denominator. So for these fractions, we're going to multiply it with beta. And for this, we're going to multiply it with alpha. So next, you're going to have beta plus alpha over alpha beta. So here is the same as alpha plus beta, which is equal to -5 over 2. We're going to divide it with alpha beta, which is -1 over 2. So this is the same as multiply it with -2. So we can cancel the number 2 that we have here. Therefore, you're going to have the answer of +5 when -5 times with the -1. Now we can find its products of roots. It will be 1 over alpha multiply 1 over beta, which is equal to 1 over alpha beta. So this is the same as 1 divided by this alpha beta, which is -1 over 2, which is also the same as 1 times -2, which is equal to -2. Now we can form the quadratic equations of a. It will be x squared minus the sum of roots, which is 5x, then plus with the product of root, which is -2 equal to 0. So let us simplify the sign here. So plus minus is -2 equal to 0. Questions B. So the roots are alpha plus 1 over beta and beta plus 1 over alpha. So first we need to find the sum of roots, which is equal to alpha plus 1 over beta. Then we're going to plus it with the beta plus 1 over alpha. So I'm going to rearrange this. So it's going to be alpha plus beta plus 1 over alpha plus 1 over beta. So alpha plus beta here, we can substitute it with the negative 5 over 2. And for this part, which is 1 over alpha plus 1 over beta, actually from the questions A, we already find the value of it, which is equal to 5. So straight away, I'm going to use the number 5 from the questions A for this part. So I'm not going to redo these parts again. So solve this, then you're going to have the answer of positive 5 over 2. Next, we're going to find the product of roots. So in this case, it will be alpha plus 1 over beta multiply beta plus 1 over alpha. So here we're going to do the expansions. So first you're going to have alpha times beta, alpha beta, and then for this part, the second one, when alpha times 1 over alpha, so the alpha will be cancelled, or it's going to be alpha over alpha, which is equal to 1. And for this part, when 1 over beta times beta, so the beta will be cancelled, it will be positive 1 as well. And the last one will be 1 over beta times 1 over alpha, which is 1 over alpha beta. Now alpha beta, we know that it is equal to negative 1 over 2. So these two will give you the answer of plus 2. The value of 1 over alpha, we already also find it in the questions A, which is equal to negative 2. So I'm just going to use the information in the questions A to solve for this part. So solve this, it will give you the answer of negative 1 over 2. Now to form the quadratic equations for questions B, x squared minus the sum of roots 5 over 2 x plus with the product of roots. So let us solve for the sign first. So here is going to be a minus 1 over 2 equal to 0. So we have a fractions here with the denominator of 2. So I can get rid of it by multiplying all of the terms here with the number 2. So here the number 2 is going to be cancelled. So the quadratic equations for C will be 2x squared minus 5x minus 1 equal to 0. Question C. So the roots are alpha square and beta square. So first we're going to find its sum of roots. In this case, which is alpha square plus beta square. So for this part, we're going to do the factorization. So it's going to be alpha plus beta square minus 2 alpha beta. Now for this part, if you expand it, you're going to get alpha square plus 2 alpha beta plus beta square. But the sum of roots here just is alpha square plus beta square, right? So therefore, we have an extra of plus 2 alpha beta. Therefore, here we need to minus 2 alpha beta to get rid of this extra 2 alpha beta here. So from the informations here, the alpha plus beta is equal to negative 5 over 2 square, and alpha beta is negative 1 over 2. So this one will give you the answer of 25 over 4, and this is plus 1. Solve this, the answer will be 29 over 4. Next, we're going to find the product of roots, which is alpha square times beta square. So here it is the same as bracket alpha beta square. Alpha beta is negative 1 over 2 square, which will give you the answer of positive 1 over 4. Now, to form its quadratic equations, x squared minus the sum of roots 29 over 4x plus the product of root 1 over 4 equal to 0. Now, to get rid of the denominator of the fractions here, we're going to multiply the whole equations with number 4. So when 29 over 4 times 4, the 4 will be cancelled here. So the quadratic equations will be 4x squared minus 29x plus 1 equal to 0. Questions D. So the roots are alpha over beta and beta over alpha. So first, we're going to find the sum of roots, which is alpha over beta plus beta over alpha. To sum this, we need to first equalize the denominator. So for these fractions, I'm going to multiply it with alpha, and for these fractions, I'm going to multiply it with beta. Next, you're going to have alpha times alpha, alpha square, plus this one, beta square, over alpha beta. Now, this part here is the same as in question C. So we can factorize this. It will be bracket alpha plus beta square minus 2 alpha beta over alpha beta. As this part is exactly the same as in question C, therefore we can just use the value that we find in question C and replace it here. So this one will give you the answer of 29 over 4. Then we're going to divide it with the alpha beta, which is negative 1 over 2. So this is the same as 29 over 4 times negative 2. Solve this, it will give you the answer of negative 29 over 2. Next, we're going to find the product of roots, which is alpha over beta times beta over alpha. So for this part, we can just simplify it. Therefore, the product of roots is equal to 1. So the quadratic equations for D will be x squared minus the sum of root, which is negative 29 over 2x, plus the product of roots 1 equal to 0. So this negative negative will give you the answer of plus 29 over 2x plus 1 equal to 0. Now to get rid of this denominator, we're going to multiply each of the terms here with number 2. Therefore, the quadratic equations for D will be 2x squared plus 29x plus 2 equal to 0. Question number 5. A quadratic equations 2x squared equal to 6x plus 3 has two roots p and q. Find the quadratic equations with roots p squared q and pq squared. So we're going to start with the quadratic equations given in the questions, which has the roots p and q. So first, we're going to write these quadratic equations in general form. So it will be 2x squared minus 6x minus 3 equal to 0. So from this general form, we know that the a is equal to 2, b equal to negative 6, and c equal to negative 3. So for these quadratic equations, as the root is p and q, therefore the sum of its roots will be equal to p plus q. As we know, the sum of roots also equal to negative b over a. So in this case, our b is negative 6 and the a is equal to 2. So solve this, you're going to have positive 3. So the sum of root p plus q is equal to 3. And the product of roots, which is p times q, also equal to c over a, is equal to negative 3 over 2. So we're going to use these informations to find the quadratic equations with the roots p squared q and pq squared. Now, for this quadratic equation, first we need to find its sum of roots. So it will be p squared q plus pq squared. Now for this part, we can do the factorizations as we have the common factor of pq. So take out the pq and put it at the front, bracket. So here we're going to have p plus q. So pq, we know that is negative 3 over 2. Then we're going to multiply it with p plus q, which is 3. So this part will give you the answer of negative 9 over 2. Next, we're going to find the product of roots, which is p squared q times pq squared. So this is going to give you the answer of p cubed q cubed. So this is the same as bracket pq cubed. So pq is equal to negative 3 over 2. So we're going to substitute it here, cube. So solve this, you're going to get the answer of negative 27 over 8. As we already have the sum of roots and the product of roots for these quadratic equations, therefore we can form the quadratic equations, which is x squared minus the sum of roots, negative 9 over 2x, plus the product of roots, negative 27 over 8 equal to 0. So first let us solve these signs first. Minus minus a plus here, plus minus a minus. So now to get rid of the denominator, 1 is number 2, 1 is number 8. So the lowest common multiples will be 8. Therefore, we're going to multiply each of the terms here with number 8. So when 9 over 2 times 8, so we can simplify it. So this one will come 4. So here the number 8 will be cancelled. Therefore, the quadratic equations will be 8x squared plus 9 times 4, which is 36x, minus 27 equal to 0.